Hello everyone, welcome to Lab 7.2. I'm Steph and today we'll be talking about the flyweight design pattern. So let's look at the design context first. In this design we'll be modeling clothing. So we have different pieces of clothing and each of these pieces of clothing has a certain color. And what we want to do is that we can easily reuse the same colors for different pieces. So you might imagine that we have two shirts that are both red, or maybe you have a shirt and some pants that are both green, or some other kind of combination in which a color is used multiple times. So what we want to avoid is creating a different color for all of these clothings while they're actually the same. So we don't want to have multiple kinds of red colors for different kinds of clothing. We want to have one red color which is used for all of these clothing pieces. So we should be able to easily reuse this. And the advantage of this is that these colors are then identical. So we can easily do comparisons with them. However, it also minimizes memory usage of your application. So if you have a lot of different colors that are actually the same, that uses more memory than if you use one shared instance for each color. So here's the UML diagram. It's quite small. So as you can see, we have a shirt and pants. They both have color. And then we have one color class. And as you can see, there is a get method on this with a string. This method will be providing us the colors and will also automatically handle for us this sharing of different colors. So if I ask it for a red color multiple times, it will give me the same red color back each time. All right, so let's go over to IntelliJ and see how we implement this flyweight design pattern. All right, here we are in IntelliJ. So I've already created the basic skeleton. We have a color class, and we have a pants class and a shirt class, which both have a color. So in this case, they are identical. They only have just a color, but you could imagine that they would have more properties than just this. So as it currently stands, we have not implemented the flyweight pattern yet. And as you can see, we create a shirt with a red color and pants with a red color. So if we both print these colors, we can see that these are actually different colors in memory. All right, so we get this. So we can see over here that these both are colors, but we can see that these numbers over here are different. So that means that they are different color objects in memory. So we have now used double the amount of memory, since we have two types of red color, than we would actually need. And that is what we want to address with the flyweight pattern. So let's go to the code and let's implement this flyweight pattern. So we want to go to the color class, and we want to make this constructor private. And we do this so that not everyone can just create colors, because that will bypass our flyweight pattern, which is obviously not something we want. Now we're going to be storing these colors in a kind of cache. So every time we get someone asks for a color, we look in our cache. Do we already have this color? If we already have this color, then we return that color instance we already had. If we do not have this color yet, then we will create one and put it in the cache. That way we ensure that we always have only one instance of the same color in our cache, and that we and in our application. So we will never have two instances with different colors. So to implement this cache, I will be using a simple map. So to identify the colors, we will be using the string for the name of the color. We'll be mapping it to a color. So let's just call this cache. Then we'll be making this a new hash map. Let me import these classes. Now, getting these colors is something that we want to make static, and that is because we cannot get a color. So if this were not to be static, we would need an instance of color to get a color. But to get a color, we need an instance of color, so you get this infinite cycle where you never can get a color. So that's why we make it static. Then we don't need an instance of color. So we make it static, and we can also make this final because we won't be changing it. Now, as we saw in the UML diagram, we had a get method. So let's create this get method over here. So we have public. As I said, this needs to be static. Get. And we'll be using the name of the color for getting this. So get, and the return type is color. And then we'll be calling this color name. So now we have our method, and this is what we'll be calling to get our color. So first we want to see if this color is already in the cache. So we'll be making an if statement cache.contains key color name. So if this color name is already in the cache, then we'll be returning the element from this cache. So as we can see here, if this color already exists, then we'll take this color that we stored and return it. So this will be the same instance every time. Now, in the case that we don't have this color in the cache yet, we want to create it. So first we will be making the actual color, new color, and then we provide the color name. Then we want to add it to the cache. So cache.put, that adds it to the cache. And then we need to specify the color name and the actual color that we just created. So this color that we create will be the one and the only instance of this type of color. So there will be no other colors with this color name. And that is because of this cache that we're implementing. So now we put it in the cache. So once we request this color that we created again, it will be retrieved from the cache instead of creating a new color. All right, and now the only thing we need to do is actually return this color. So we return the color we created. All right, now we need to go back to our main. As we can see, this is now no longer possible because we made our color constructor private. So if we would not have done this, we could still accidentally do this, and our flyweight pattern would be bypassed, and we would still end up with multiple instances. Right? So this will be a design issue because if you expect all these instances to be the same, and they end up not being the same because somewhere you create this constructor yourself, then you might break your code. So how do we get color now? We use the get method that we just created. So we type color.get, and then we just provide the name in here. So red. And we do the same over here. Color.get red. So now we have used the flyweight design pattern over here. If we run this code now, you can see that we still get this, but you now see that this hexadecimal number at the end is the same. So now we can see that these two colors, these two reds, both refer to the same instance in memory, and no longer to different instances as we just had before we implemented the flyweight design pattern. This also has the advantage that we can compare these by using these equal sign. So if you watch a previous lecture, you will know all about object equality. However, since we now have these shared instances, this will actually be true, right? So since we share these instances, this will turn out to be true. Let me demonstrate that. We can see true. So these two colors are actually the same instance in memory as well. And you can now compare them with this double equal sign instead of having to use the dot equals method like you otherwise would. All right, so that is how you implement the flyweight design pattern in Java. Hopefully this was useful, and I hope to see you again in the next lab video.